might have a nest up on the roof.
One of the keys in looking at traces, looking at these rocks in general, is sort of knowing what you're seeing from the view that you're looking at it. The side views are very different from upper views, looking at the upper surface. So you get a totally different perspective if you look at these rocks this way than if you look at them this way. So who's found a trace?
Is it like a circle thing like this?
Oh, let's see.
Here?
Oh, that looks pretty good here. Both those look pretty good. Yeah.
Too round for...
Yep. So those are probably vertical tubes, just straight little vertical tubes that are going down.
What's this one?
That, it's a little hard to tell because what you get in these rocks,
a square.
this thing and this thing over here and this thing, you get iron forming inside some of, and sometimes they will actually line burrows or fill burrows, and then fills it with this iron mineral that then rusts and gives you these orange nodules that when it rusts out. Yep, so anything that makes a vertical hole is going to leave a, in this section is going to leave a circle.
So all these things?
So all of these little black dots are...
Well, now these, all of these little black dots there, yep, those are all traces.
Oh, okay.
How old would you think they would be?
These are same age as the rock, so they formed when the rock was accumulating, and that's 50 to 55 million years as we can guess. Oh, actually, that's one that we see a lot in here. It is a tube which has mud pellets packed around the outside. Can you see the mud pellets on that?
Mm-hmm.
And they do that. Here's another one. I think this is probably another one right there. And they use that as an engineering design to keep the burrows from collapsing. So they make little pellets of mud and they stick them around the outside of the burrow.
What kind of creature is it that does this, that can do this?
This is one of the few that we know has a modern analog. And ghost shrimp on the East Coast do this. Ghost shrimp on the West Coast don't. But ghost shrimp on the East Coast do. And look at this. Look over here. See the little tiny white things?
Yeah.
And then look at this tube coming down there. Over here. We look over here. All of this.
Oh yeah.
There's a big tube here. There's another one there. This is the one I call the cruising bruiser, because he just sort of cruises through the sand. Interestingly, we have another trace here that we don't see right here, which is called helichnus, and it looks like featherboa kelp. And it is sort of the definitive trace at Point Lobos. Wherever you get helichnus, you don't see the cruising bruiser, which is called scalesia by trace fossil people. And where you see the scalesia, you don't see helichnus. We know that this kind of a burrow is made today by burrowing urchins in fairly shallow water, but what does it at these water depths, we really don't know. Now we got some sand-filled tubes over here, and this one looks like it's starting to branch, and almost get a sense of which way the animal was moving because there's sort of a C or a U in there inside the burrows, and they tend to pack the sand behind them as they work their way through the burrow. What this was an open burrow that the organism selectively backfilled with sand, punch sand off. The gophers. You get a whole bunch of different feeding behaviors. You've got the ones that feed on the sand or the mud. You've got the ones that are filter feeders that come up to the surface and they're filtering stuff out of the water. And so
I was just trying to think why you'd eat sand.
Because that's your living. Sea cucumbers do this. So if you've been to the aquarium and seen the sea cucumbers, they crawl around the bottom and ingest the sand. They're basically deposit feeders, and they poop it out behind. If you're diving and you encounter a thing that looks like a string of little pieces of broken pencil, you keep following. Each one of them is a little rod filled with sand. Down at the end, you'll find a sea cucumber. And so people at the aquarium are fond of saying that every grain of sand on the beach in Carmel has been through a sea cucumber's gut. So, you all recognize this guy now?
Big cruiser? Or
yeah, that's our cruising cruiser.
Okay, let me see.
Yeah, Scalicia is...
Okay.
Yeah.
Oh, okay.
Scalicia is the name. Now, we've got one here. This is a little tiny.
Oh, yeah.
Oh, can you see this one in the clear?
Yes.
Yeah, that's Helminthopsis.
What is it again?
Helminthopsis. Or actually, what those are little mud-filled burrows. And sometimes there are places, and you probably need the rocks just the right amount of dryness to see them. Here they are down here. Not the best focus, but notice how down here there are little white halos around them, little white colored halos. This is probably some sort of worm, I'm guessing, that feeds on the mud, is ingesting the mud and excreting it out behind it as it crawls through, leaving a mud tube in the rocks and feeding on the sand, cleaning the sand up just beyond the center of the burrow, and so it leaves this white-colored halo, this lighter halo, where the sand is cleaned up. You can't always see that light-colored halo. It's pretty hard to see.
Can you see it here?
The halo?
Yeah.
I thought maybe, but it could well be imagination. But this one over there looks like there's a little whitish ring right around the burrow itself. Yeah.
Yeah.
Here are these tubes. There's this thing over here. There are all these little guys down here. Here's something that goes across through the sediment this way. There's it's like a vertical burrow. Here's one over here. And on and on and on and on. You get up here and things are so messed up that it's really it's really stirred up.
Almost like that feather boa type creature could be here.
And you're absolutely right, because here it is.
Yeah.
We're getting up to the trace fossil, and this is the only fossil I would recommend remembering the name of. It's called Helichnus, and even then I don't think you read the name. I tell people it's a kelp-like trace, or a trace. This is a very mysterious phenomenon in the rocks, and in this case it looks like it's actually in the sandstone. Usually it's in the muds, where you get iron nodules growing. How they grow, why they grow, I don't have a clue. But you get iron, it's just a lump of iron carbonate that takes over and replaces everything that's there. And then, that's kind of, in this case, what it's done is cement the sand. And you see how resistant it is? These stand up, but they also weather. You can see that they've got iron in them because of the red color. And they're weathering.
And the beautiful pattern in the rock, is it just different layers, like?
Different, it's a combination of different layers. You get a totally different view if you're looking down this way than if you get down on your hands and knees and look this way, parallel to the layering. So again, the angle at which you see the rocks is really important for identifying the traces. Harder to see. Oh, these things. Yeah, those are great.
The mudstone.
They are a trace fossil.
Say that one more time.
Trace fossils. Mary, you ought to know what they are.
Well, you told me. But it's kind of obvious. If I have it right, the purple sea urchins burrowed there.
Oh, okay.
So.
And they're relatively new?
Yeah. They formed on this surface. A friend of ours at the aquarium used to come here as a little girl in the 40s, and she said this whole surface was covered with purple urchins. And that was before the otters came in. And now you've got a few things like this that indicates how abundant they were. One of the most spectacular displays of traces. And it is our Helictis. Although it's a little different manifestation, but you can see the feather bullock kelp character there. You can see it again here. But this is a really good place to show that this is not a fossil kelp. And I still get arguments from people that it is.
It's actually an animal that's walking through it.
Right. Now, how could you tell that? How could you tell that this was not a plant trace, but actually something that was produced by an animal?
Can you see his paw print?
Well, in your article, it has something to do with 3 dimensions versus a flat dimension.
Now look at this trace that comes across here.
Oh, yeah.
See how it breaks down and goes down at depth? Now they to them. They're not a leaf superficial. And if they were a piece of kelp that was essentially frozen in the rocks, one, it would be flat, like a leaf impression, and two, the second thing is that the dark material would be carbon, like a leaf impression. The dark material here is mud. So those two things were what led me many, many years ago to dispute the idea that this was produced with a fossil seed. Okay, can you find any trace fossils here? See the little tubes hanging down? Probably burrows into the underlying mud. When the sand bed came down, they were filled, and up here, burrows into the top of the sand bed. So the first question is, can you see any of them when these rocks were standing on?
Yeah. Oh, right here
Yep.
and here.
Yep.
Yeah. In fact, you're standing on it. So
And
go
here.
back. Yeah.
And here. And there. There. And here. And here. So this, we're going to see a lot of these, and this is a good place to show you one interpretation of how they form. Old tubes, but these you can actually see the halos around them. See this one right there? If you look at them, almost every one has a lighter colored halo right around the outside. So they're feeding on the sand, pulling out that sand, or pulling out the mud from the sand, which cleans it up a little bit, and then they poop the sand out behind them as they go.
And that's what makes it wider, because it's cleaner.
It's cleaner, exactly. But that's a great example of, you can really see the halos there. But these are, and there's a network of small tubes down here. You start seeing them. See them right here?
There. Yeah.
There's a real network. But these are just, and some of them are really long.
These trails are not the bruisers?
No, those are the tubes.
The white one.
So that the less erosive rock is standing out now.
Yeah.
So this is more the Ophiomorpha, the pellet line tubes,
Okay.
which are branched and sometimes intersect one another, but they've got the pellets on the outside. So that's the Ophiomorpha. That's the pellet packer. Here are a couple of good ones here.
Oh, yeah. Pellet packer.
Yeah, I hadn't thought of that as a name.